I'm Sabir Ahmed, a first year computer science PhD student at Binghamton University. I am a joint first author of our paper SSDA Secure Source Free Domain Adaptation, which is a joint work with our collaborators from NC State University and University of Central Florida. Domain shift is the discrepancy between training and test data distributions. It challenges the model's ability to generalize, causing suboptimal or even disastrous performance when deployed. Domain adaptation was introduced to solve this problem. In domain adaptation, the training dataset is often referred to as source domain and test dataset is often referred to as target domain. Traditional domain adaptation relies on label data from both source and target domains. In 2020, a new framework called source-free domain adaptation was proposed that does not require access to source data and does not require target labels. The motivation behind this was that source dataset often remains confidential due to privacy constraints, and target data often lacks annotated labels. Traditional domain adaptation performs feature alignment by accessing both source and target data, while source-free domain adaptation, in short SFDA, aims to adapt models without direct access to source data. In this work, we consider a threat model where a malicious source domain owner, that is the attacker, has access to source dataset and source model training. The attacker can poison source dataset during training to create backdoor source model. Then what is the expected behavior of the target model when it is adapted from this compromised source model? We find that the target model also behaves maliciously similar to the backdoor source model. Thus, we conclude that SFDA in current form is not secure. Given this severe security threat of SFDA, the target domain owner needs to defend this attack while adapting the source model. There are several existing backdoor defense methods. However, the major challenges with adopting existing defense methods is that they either require access to source dataset or target labels, which is not available in SFDA. Thus, we have two main observations. The first one is that SFDA in current form is not safe. And the second one is that none of the existing defense methods can defend this threat. Then how can the target domain owner defend this attack? The target domain owner faces three major challenges. The target domain owner has no access to source dataset, has no target labels, and cannot train the classifier. Then how can the target domain owner overcome these challenges? The possible solutions are that the target owner needs to adopt data-free techniques for defense. And the target owner also has target training phase which can be utilized for defense. Our proposed method SSDA contains two components which can defend this attack. The first one is the static component, which prunes the most sensitive channels that are potentially backdoored. And the second component is the dynamic component, which dynamically compresses the sensitive channels during target adaptation based on spectral norm penalty. From the results, we observe that our SSDA successfully eliminates this security threat against multiple state-of-the-art backdoor attacks. And even in the case of benign source training, that is no attack, our SSDA's adaptation performance does not deteriorate. In summary, we demonstrated a major security threat for SFDA by considering a source adversary. In particular, we showed that a backdoor source model results in an equally backdoor target model with current SFDA methods. And none of the existing defense methods can defend this attack in the target domain. Thus, we developed a novel target adaptation framework, SSDA, that eliminates this major security threat for target domain owner. Finally, I'd like to thank our collaborators from NC State University and University of Central Florida. Thank you for listening to the presentation.